Let's get right to it. Welcome to today's explainer. I am absolutely thrilled to have you here because we're about to dive into something we literally all use every single day, but honestly, very few of us actually understand. We're going to look at how the internet actually works. And right out of the gate, I want to challenge your assumptions. Forget the magic, forget the mystery. By the end of this explainer, you're going to have a crystal clear picture of the very real, very physical system running right under your feet.
So first up, here's a fascinating question. Where does the internet actually live? I mean, if you ask most folks, they picture it as something invisible, right? Like it's just floating in the air all around us, or living up in some nebulous cloud in the sky, or maybe getting beamed down from satellites in space. It's a really cool mental image, but here's the truth. Almost none of that is real. Look at this number, 99%. Just let that sink in for a second. Roughly 99% of international internet traffic doesn't go through satellites in space at all. Instead, it travels through thick, physical, fiber optic cables that are literally lying on the ocean floor, connecting our continents. The internet is overwhelmingly physical. We're talking about actual wires and glass cables carrying pulses of light across the globe. Which brings us to one of my absolute favorite quotes, and it completely shatters the biggest myth we have. The cloud is just someone else's computer. That's it. There is no fluffy cloud up in the sky holding on to your data. The cloud is just a friendly, marketable name for a physical server sitting in a very real, heavily air-conditioned building somewhere. When you send a message across the world, it is physically racing through those glass cables under the sea and back. Okay, so what are the ground rules here? At its simplest, the internet is just a network of networks. It's billions of devices, internet providers, universities, and businesses, all voluntarily agreeing to plug into each other. And the entire trick to making this work is that they all agree to use the exact same shared rules to talk to one another. We call those rules protocols, and the main one running the show is called TCP/IP. No single company or government owns the internet. It is really just a massive voluntary agreement. To really grasp how information moves across this massive physical infrastructure, we need to introduce our cast of characters. We can basically break the whole shebang down into 4 core ideas: addresses, the phone book, packets, and routing. If you understand these 4 concepts, you understand the internet. Let's start with idea 1, IP addresses, or the internet's postal system. Just think about how a normal house works for a second. A house needs a postal address to get physical mail, right? Otherwise, the postman has absolutely no clue where to drop off your letters. Well, the internet works exactly the same way. Every single device connected to the internet gets a unique number, and that serves as its online identity. Without it, nothing could ever find your device. When the network is trying to send data, it isn't looking for a name. It's hunting for a specific string of numbers just like this one. Oh, and quick side note, the format you see here is the older version, called IPv4. Because we have so many devices in the world now, we're actually running out of these combinations. So the world is slowly switching over to a newer version called IPv6, which gives us an almost unlimited supply of addresses. Moving right along to idea 2, DNS, or the internet's phone book. Here is the core problem. Human beings are notoriously terrible at memorizing long strings of random numbers. Nobody wants to type out 142.250.183.206 every single time they want to search for something. We like words, we like names. But the network, as we just saw, only understands numbers. So we need a translator. You type the human-readable name, google.com, and instantly the domain name system, or DNS, steps in. DNS is literally the internet's phone book. Every time you type a web address, the very first thing your computer does is perform a quiet DNS lookup. It takes the name you typed, looks it up in the phone book, and hands your computer back the machine-readable number it needs to actually connect. And it happens completely seamlessly in the background. Now we reach idea 3, packets, or chopped up data. Now, this is where things get genuinely fascinating, because this is probably the most counterintuitive fact about the entire internet. When you send a big file like a high-res photo or you load a heavy web page, that data does not travel as one giant single chunk. If it did, it would easily clog up the whole network. Instead, the internet chops your data up into thousands of tiny pieces called packets. A packet is just a small slice of your data bundled with a set of instructions. And those instructions tell the network exactly where the packet is going and how to rebuild it once it gets there. Think of it like this. Imagine trying to mail a massive, heavy book. Instead of mailing the whole thing, you tear out every single page, stuff each page into its own numbered envelope, and drop them all in the mail. They might all take entirely different paths to get to the destination, but once they arrive, the recipient uses those numbers on the envelopes to put the book perfectly back together. That is exactly what happens with your data, just in a matter of milliseconds. Which brings us perfectly to idea 4, routing, the post offices of the internet. If all these millions of little packets are flying around taking totally different paths, how do they actually find their way? Well, they do it through devices called routers. You can basically think of routers as the post offices or the traffic cops standing at every intersection of the internet. A router just reads a packet's destination, checks its internal map, and forwards that packet to the next best step toward its target. It works hop by hop. It starts small. Your packet hits your home Wi-Fi router. From there, it gets passed to your internet service provider's routers. Then it scales way up, hitting massive backbone routers that do the heavy lifting, moving data between cities, countries, and across those underwater cables. These big networks decide how to hand off traffic to one another using a specific protocol called BGP. Finally, the packet travels back down the scale until it hits the exact destination server. So the really crucial point here is what happens when things go wrong. Like, what if a ship's anchor drops and actually cuts one of those undersea cables? Or what if a route gets totally congested with traffic? The genius of this routing system is that it is dynamic and self-healing. Routers are constantly talking to each other. If a path fails, they simply update their maps, and the packets instantly start flowing a different way. That incredible adaptability is exactly why the internet keeps working even when physical pieces of it break. Okay, let's put it all together. Welcome to the climax of our explainer. The journey of a click.
We've met all the characters, so let's set the scene. Imagine you're sitting at your computer. You type youtube.com into your browser, and you hit enter. What exactly happens in that tiny fraction of a second before the video pops up on your screen? It's literally a 6-step action sequence that happens in a flash. Step 1, DNS lookup. Your device asks the phone book for YouTube's numerical IP address. Step 2, connection. Your browser does a super quick handshake with that IP to agree they're both ready. Step 3, request. Your computer asks for the web page, sending the request out chopped up into packets. Step 4, the journey. Those packets race through your Wi-Fi to your ISP, across those massive backbone routers, maybe even diving under the ocean, all the way to a server in a data center. Step 5, response. YouTube's server fires the video data back exactly the same way, chopped into thousands of new packets. And finally, step 6, reassembly. Your browser catches all those packets, glues them back together in the right order, and draws the web page on your screen. All of that happens in well under a single second. Absolutely wild.
Before we wrap up, let's slow down for just a second to clear up one final very common point of confusion. The internet versus the web. People almost always use the words the internet and the web interchangeably, like they mean the exact same thing, but they really don't. The internet is the actual infrastructure. It is the physical road system, the glass cables, the routers, the network of connections, and those TCP/IP rules that govern how data moves. The World Wide Web, on the other hand, is just one service built on top of those roads. The web is the collection of websites you visit using a browser. There are plenty of other things, like your email, online video games, and messaging apps that ride on the internet's physical roads, but they aren't actually part of the web itself. Think of it like this. The internet is the highway. The web is just a really popular set of destinations you can drive to. So what is our ultimate takeaway today? There is no magic floating in the sky. The internet is an incredibly fast, highly organized, very physical global network of networks. It chops your data into tiny packets, addresses them like mail, looks up the destination in a phone book, and routes them hop by hop across the planet, often through glass cables resting in the pitch dark on the ocean floor, to a physical computer in a building somewhere, which then sends a reply racing right back. It is an extraordinary, self-healing postal system moving at the speed of light. I really hope this explainer has completely transformed how you see the digital world. I'm going to leave you with this final thought. The next time you click a link or send a photo, will you pause for just a millisecond to picture those pulses of light racing through glass cables under the ocean floor? Thank you so much for watching. Keep your curiosity alive, and I will see you in the next explainer.